Welcome. So this is Mr. Simon, and we are here to change our world with chemistry. So we are studying Senior 5 Chemistry, and welcome to our new unit, which is Conductivity of Solutions. And our lesson today, we are actually going to talk about conductivity and the conductance. Conductivity and the conductance. So here, so by the end of this lesson, students should be able to explain conductivity and conductance of what? Solution. So what is this conductivity? What is this what? Conductivity. This conductivity is actually a branch of electrochemistry, meaning we are going to involve electricity. And also, and electrochemistry is actually a branch of physical what? Chemistry, which is actually concerned with transfer of electrons from one species to another, and the relationship between electron transfer and electric what? Current. So as you see in our illustration here, we have electricity passing through a solution here, and we have also electrodes. So you observe this solution can conduct electricity, and the bulb will even continue what? Lighting. Continue lighting. So we even have more illustrations here of how our solutions can conduct what? Electricity. So electricity can pass through a solution, and as it is passing through the solution, it conducts electricity, and even our system will continue what? Operating. So we have example of fruits also, meaning in fruit we have electrolytes, which can also conduct electricity. So as a little bit of our introduction, let's talk about electrolytes. So electrolytes are substances which conduct electricity in either aqueous or molten what? States. Then we have many examples. Who can give us examples of electrolytes? So examples, yeah, there are very many. Actually, we can divide our electrolytes into two types. We have what we call the weak electrolyte and the strong what? Electrolyte. Weak, it's good we talk about this, where we have weak electrolyte. Weak, if the electrolyte is weak, electrolyte, and also we have strong electrolyte. So this electrolyte should be able to conduct electricity. So, but basically concentrate in the solution form, because we have many conductors, as we shall see in our next discussions. So weak electrolyte we say, actually, who can define for us the definition of a weak electrolyte? Yes. So weak electrolyte is a substance which can conduct electricity, which actually, okay, we are going to say conduct electricity, but again, in addition to that, we actually say is a substance which partially ionizes in what? In solution. Then a strong electrolyte fully ionizes in what? In solution. So here we have examples. Normally we have examples of weak. Who can give us examples? So we have ethanoic acid, which is a weak what? Acid. You can have also weak bases like ammonia, like what? Ammonia, etc. Then strong electrolyte, those which conduct electricity, which actually fully ionize in what? In solution. They conduct electricity, yes, but they fully ionize in the solution. So we have example, Ig, have sodium hydroxide. Who can give us more examples? This is the base. We have strong acids like HCl. Give us more examples. We have also sulfuric what? Acid. So briefly look back, you'll observe that a weak electrolyte, we said a weak electrolyte actually partially ionizes. So we normally represent it like that. Partially what? Ionizes. Then for a strong electrolyte, like for example, sodium hydroxide or sodium chloride, will fully ionize. Will fully what? Ionize. So that's a brief revision about senior 4 work. Just a representation. But all of them, they can conduct electricity, either in aqueous state or in molten what? State. Then we have those which are non-electrolytes. They do not conduct what? Electricity. They don't normally conduct what? Electricity. Then we can talk about conductor, because somewhere in our topic we shall be using the word conductor. Conductor is a substance that allows electricity to pass through it, and a non-conductor is a substance which will not allow electricity to go through it. So we have a relationship here by allowing electricity to flow or to go through a substance. If the substance allows electricity to go through it, we say it is a conductor. If it does not allow electricity to go through, it's a non-what? Non-conductor, meaning weak electrolytes and strong what? Electrolytes. All of them are conductors. They are all conductors. So, briefly, as we go to our topic, we are going to talk about this definition of conductance. Then we talk about conductivity. We talk about what? Conductivity. Actually, conductance of a material or a solution is a property of materials due to which a material allows the flow of ions or electrons through itself. So you observe that there is a relationship between flow of electricity and flow of ions and flow of what? Electrons. So as electrons are moving, so it's normally when electrons are moving this side, as they give electric current on the opposite what? Side. So as the electrons are moving, meaning they will dispatch electric what? Current. So there is a relationship. So meaning this conductance is a property of a solution to allow flow of electrons or to allow electricity to go through it. So mathematically, we are going to say that this conductance, we are going to give conductance a symbol, conductance, a symbol G. And we are going to say that actually conductance is a reciprocal of resistance. Is a reciprocal of what? Resistance. Yeah. So you remember resistance in mathematics or in physics? So we say resistance, units of resistance are normally ohm. Ohm. Or we say like this, per ohm. Actually, not per ohm, it is ohm. This time we are talking about units of resistance. So these are units of resistance. Then meaning units of G, units of G is just a symbol. You can use any symbol, but this time we are using G as our symbol. So here, ohm is per ohm, or we say like this, per ohm. By ohm. Those are our units. Sometimes we call them the Siemens. Those people who are supporters of Real Madrid, I think you've seen this thing. But it has a relationship with electricity. So then we have also conductivity. Someone may ask what's the difference between conductance and conductivity. We are going to give it. So conductivity, if you look at your screen, we are going to give conductivity a symbol of K. Sometimes we call it kappa, coming from another language, Greek or Latin. So here we are going to say that this conductivity, from the definition, it has also a mathematical definition, is a reciprocal of resistivity. Reciprocal of what? Resistivity. Yeah. So this is for, you can call this, it's good for us to write that this is the resistivity. Resistivity. It's good for you to recognize. So we continue. So we are going to look at a relationship. We are going to look at what? Relationship between G and K. That's the relationship between conductance and what? Conductivity. Yeah, and conductivity. So we can get it from this law, which says that the resistance of an electrolyte is directly proportional. This has been proved to the distance I between the plates. So if you look at your screen very well, you'll observe that these are our plates, and the distance between them is L. We are going to use L to represent the distance, and also inversely proportional to the cross-sectional area. The cross-sectional what? Area. So you'll observe that here, cross-sectional area of each plate. So we are going to, maybe we can illustrate it here better. We are looking at the relationship between that is G and what? And K. So we are going to get it from our illustration. So what you see on your screen are actually diagrams to show you electrolytic cell, or we can call it a conductivity what? Cell. So here we are going to say that the resistance of the electrolyte in solution, electrolyte in what? In solution, is directly proportional to the distance between the electrodes and inversely proportional to the cross-sectional what? Area. The cross-sectional what? Area. So we can remove this proportionality and we put a constant, which is our resistivity, like that. Constant of proportionality. So you recognize that this time resistance is actually a constant. Resistivity is a constant of proportionality. But remember, I want to look at this relationship between G and K. So from there, but remember we said that our G is equal to 1 over what? R. 1 over what? R. So if I replace this R here, so meaning our R again can equal to 1 over G. 1 over what? G. So I can replace it. So replacing this R with 1 over G, so we say 1 over G will equal to our, this one, resistivity, and L over A. L over A. So we can cross multiply and we say that G is actually equal to A over resistivity times the cross-section area, the distance between the electrons. So we are going to say that actually, if you recognize value, we can say like this. This one is 1 over, you can write it like this, resistivity times A over this one. So our G will equal to K A over A over E. K A over E. Yep. So this is actually so we have something like root E. So we have something like that. So you said here actually here we have K, yeah, K. So we have cross multiplied here. I've cross multiplied. And over A. Yeah, A. So we continue. So we are going to say that, but electrolytic conductivity is the reciprocal of resistivity. Is the reciprocal of what? Resistivity. So here, so you observe that we can have our resistivity. So you recognize here we have electrolytic conductivity K will be equal to 1 over resistivity. So our resistivity here, our resistivity here will equal to A. Resistivity will equal to A over G what? GL. Then we can also say that our K, we can make K the subject of the formula, and say K. So from here we say K, this K, which is our conductivity, will equal to So electrolytic conductance, so we are going to say that 1 over L is our cell constant. So electrolytic conductivity is the conductance of the solution placed between electrodes of 1 centimeter apart and area of 1 centimeter squared. So from there, we can be able to get the units of our conductivity. So conductivity K will equal to per ohm per meter. Per ohm per what? Per meter. Or we can say Siemens per what? Per meter. Or we can say per ohm per centimeter, like that. Those are all the units. There are very many. So we can measure in centimeters or in what? In meters. So here, we are going to talk about the differences between the conductance and the conductivity. The differences between conductance and conductivity. So conductance, we can also call it the observed conductance, and conductivity, we can call it the specific what? Conductance. So one of them, the first difference is one is the reciprocal of resistance. Another one is the reciprocal of resistivity. Then conductance depends on the dimensions of the conductor, and conductivity does not depend on the dimensions of the conductor. So those are some of who can give us more differences here. Yeah, you can give more differences. So we are going to see how we can measure our conductivity. So we can measure our conductivity of an electrolyte by placing the electrolyte inside our cell here, the conductivity cell. So we should know two things. One is the resistance. We should also know the distance between the electrodes. Also, we should know the cross-sectional area. So what we need to do, as long as we have those measurements, we just pass our current through it. And by using Ohm's law, that is V is equal to IR, we can easily determine the resistance. So from our expression K is equal to 1 over R, that is L over A. We can be able to get our conductivity. So we have R, we can use Ohm's law, we have the distance between the electrodes, and we also have the cross-sectional area. So NB is good, we use alternating current to avoid what? Electrolysis. So we are going to have a trial question here. We have a trial what? Trial question saying using the same conductivity cell, the resistance of 0.1 molar potassium what? chloride and 0.1 molar bromoethanoic acid were found to be 24.6 ohm and 66.5 ohm at 20 degrees centigrade. The conductivity of potassium chloride is 25 degrees centigrade, and that is our conductivity. Then they are telling us to calculate the cell what? Constant. Calculate the cell constant. So we calculate the cell constant. The second question is calculate the electrolytic conductivity of bromoethanoic acid. So we are going to see how we calculated. The first thing is for us to be able to note the resistance and the conductivity of potassium chloride. Then from there, we have our resistance at 66.5 resistance. So, but K, we said K is equal to this one times this one. Then we have L is equal to, L is our G. We can use L or G. G is equal to 1 over R, but K. So from there, we can say that Kr is our cell constant. Our cell constant. So using the data of potassium chloride and the data of only the potassium chloride, that is conductivity and the resistance, we can be able to get our cell what? Constant. So because this cell, we are using the same cell as we have said in a question. If you can look at our question, they're saying that using the same conductivity cell, the resistance of 0.1 molar potassium chloride solution and 0.1 molar bromoethanoic solution was found to be that one. So this cell will have the same cell what? Constant. If you remember very well, we tried to talk about the cell constant here. The cell constant, which is L over A. So for this cell, this is supposed to be a what? A constant. It's supposed to be a constant. So we calculate and get our answer. You can check your answer using your calculator. Then the second question here, the second question is asking us to determine the electrolytic conductivity of bromoethanoic what? Acid. So we go back to our formulas. Then like we see here, we go back to our formulas, and then we find here, you see, we have conductivity is equal to the distance between the electrodes, then cross-sectional area and resistance, and what? Resistance. So this L over A is actually our cell constant, which you have already got up here. We already have it. So we divide by the resistance. The resistance of what? Remember, we have two resistances. One of them is for potassium chloride, another one is for bromoethanoic what? Acid. So we use the one which is 66.5, and we divide units. So our cell constant has per centimeter, and our resistance, our what? Resistance will be, is supposed to have our units as per ohm per what? Per centimeter. Per ohm per centimeter. So that is one of the questions. Then let's quickly talk about, I'm going to leave, we are going to talk about the second question here. They are saying that using, again, the same, question, the cell resistance. So the cell resistance of 0.1 molar sodium chloride is 50.6 per ohm. Per ohm, that's the cell resistance. Then the cell of 0.02 molar potassium nitrate has resistance of 185 ohms if the conductivity of sodium chloride is. So then again, they are asking us to calculate the cell constant. So we have seen how to calculate the cell constant, so you're going to try it out. Then also the electrolytic conductance. This time, this is our G, the electrolytic what? Conductance. So we can briefly go back and talk about this conductance. this conductance here. Conductance here is we said is a reciprocal of resistance. Reciprocal of what? Resistance. So when you look very well, we have said that conductance is reciprocal of resistance. Let's briefly, yeah. Then from we said R can equal to LP, that L times resistivity divided by cross-sectional what? Area. But conductance is a reciprocal of what? Resistance. So what is conductance? So conductance will be 1 over R. So, but we say R is equal to this one. So we get this R here, and then we substitute it here. Then we can be able to get our G. So this cross-sectional area here, you observe, will help us to be able to determine the electrolytic conductance. Electrolytic what? Conductance. So let's briefly again go back about our electrolytic conductivity. So electrolytic conductivity here, we said is the reciprocal of resistivity. But again, we have seen our resistivity here. So we can make it the subject of the formula. So you observe that resistivity will equal to A over GL. Then means that this G here is our conductance. Is our what? Conductance. G here is our conductance. So you observe that the electrolytic, we are talking about conductance. So you observe that here in this relationship, we can use this relationship to be able to get our answer. So if you see very well, when you are talking about conductance, this conductance, we gave a mathematical definition. We gave a mathematical definition of conductance, and we say that this mathematical definition, can call it even a physical definition, is equal to G equals to 1 over R, where R is the resistance. But remember, we say that from Ohm's law, V can equal to I what? R. So we can say R is equal to V over I. So we can use this to be able to get the resistance, So I'm leaving you with this work today. Make sure you try it out. Thank you very much for following me. We shall meet next time. God bless you.